Thank you, thank you. So I've titled this AI Agents for the Rest of Us. And apparently, I wasn't the only one that's ever made that title or description. Even like Svelte, a JavaScript framework, they say web development for the rest of us, which is quite a claim. There's Startup for the Rest of Us, which is a great podcast, highly suggested. Functional programming for the rest of us. But I really like this idea of for the rest of us. But it kind of begs the question of who is us? So I want to just poll the room. Is there anyone that's like doing AI agentic research here? Any AI agent researchers? Cool. So we are us. Perfect. We've made it. I was a little bit worried. There might be one or two here, but I think there's a world of people kind of pushing or this technology forward or researching this technology, and then there's us. The rest of us that either need to adapt or apply this technology in some type of way, or just kind of curious about what it can do. And that's kind of really where I sort of designed this presentation to kind of sit at. My name is Korey Stegared-Pace. I am a senior cloud advocate at Microsoft, specifically working on our AI products, so primarily what we call AI Foundry, which is our central hub for deploying AI models and also agents. What I like to say my job is like filling a lot of gaps. So within our product teams, we have gaps because sometimes at Microsoft, we like to build things, but we don't know how developers or engineers will actually use them. So I go out into communities and kind of understand how it's getting feedback and understanding how they would sort of apply it. And then on the side of developers or engineers, there's a lot of gap within the world of just this rapidly changing technology and gaps of knowledge because we can build things, but if no one knows why or how to use those things, it's kind of a waste, right? So I try to say that's what my core goal is, and hopefully today will fill some gaps for you as well. I don't have a sales goal, so I don't sell any Azure or anything like that, so you can ask me, but we have a lot of talented folks that can do that for you within Microsoft, so I can point you to that. I will be using or showing at least Microsoft technology, because that's what I use every day, but a lot of the higher level concepts I'm going to cover anything from different frameworks you might want to use or different LLM providers out there, so no worries there. And then you can find me on the internet, Korey Space, on GitHub, LinkedIn is primarily where I'm most active. And I think when we talk about for us, even in the world of just AI engineering, which I don't know if any of you identify as an AI engineer, but there was this poll that was just recently released, and this is like a screenshot of a screenshot, so it's kind of blurry. But it basically was a poll around this AI engineering conference, I think it was last week, about what's the most painful thing it is to be an AI engineer. And the first one was evaluations or evals, which is what we're going to cover today as well. But the second one, and by far, if you compare the other ones, was keeping up with the rapid changes. And that's, again, what I think the goal today is to kind of hopefully bring everyone up to speed in terms of what has been changing, what are these new acronyms, new things that are out there, and make sense to it, both from a conceptual side, but also what it looks like through code. Sadly, privacy and security, if you see here, was like the bottom of that. So I won't be covering that, even though Microsoft has a great story about privacy and security. But if you're a security analyst, they're like, please don't throw anything at me. I'm happy to chat about security after the fact. But again, I think if we're talking about the main concerns about people building here, it's really around kind of understanding the rapid changes first, and then probably how they apply to security and privacy as well. And there's a lot of questions when I do events for Microsoft or go to conferences or work in the community that we get, which is like, what are AI agents really good at? First and foremost, do I really need an agentic framework? I came from the world of JavaScript before switching to Python, and we have the word framework is very triggering because we have many frameworks. So when you see new agentic frameworks coming out every week, you think it'll worry do I really need this, or is this trying to sell me something or tie me into some sort of vendor? What is even MCP? Why not just use APIs, which is a very relevant question when you're looking at this technology. How is agent to agent as a protocol? How is that different to working with multiple agents within your environment? And even did you just make up another acronym? Because every week you log into LinkedIn or any social media, you'll see someone thinking, oh, this will change the world, this new thing, this new tool. And how does it actually do that? And maybe you're just tired. Is there anyone just tired of it all? You can be honest, we're all friends here. Perfect. Two honest people. I'm a bit tired sometimes, and this is like my daily job. So I can understand, again, if this is not your core focus, because you see all these things and you don't really know how to connect. Obviously, you're here at an AI conference, so you're probably less feeling the AI fatigue than most people. But this is definitely something, especially when you're making content like I am doing, we kind of consider. And if we look at like different phases of this world of working with agents or just AI as a whole, there is one missing called phase 0, which is like you're not even doing anything with AI or not interested at all. But phase 1, at least in terms of what we've been looking at in terms of the technology, is human with assistant, right? We have either applications, AI applications, whether that's just like a ChatGPT or a Copilot, and these are assistants. They help us do the work that we would want to do primarily, or give us some sort of answers or retrieve some information that makes that work easier. Then we kind of move on to phase 2, which is kind of like human and agent interaction. So we maybe have one human and multiple agents kind of coordinating for that particular task. And then phase 3 is now we're actually having like human-led. So maybe we're coordinating with humans, but we actually have all the agents operating the primarily task. And this doesn't, it sounds kind of maybe futuristic out there, but inevitably, this is where we're going to head to, where we're going to look at, as an employee or a user, you're an agent manager and not just a user of agents. And to be honest, one of the directors of my team, he actually, in a meeting really recently, talked about how we're going to need to sort of skill up on managing agents, like as a skill. And it was like not just because it was like, oh yeah, in the 5 years time, but like today, what we need to learn how to manage agents. And I'm very curious, like if that's going to be a part of like the performance review, and they're going to ask your agents one day how well you are as a manager, and could be scary and it could be interesting. But treat your AI agents well today, and they'll pay you back tomorrow, is what I would say. And I guess the best place to start in this journey is what are agents. I know there's going to be many different talks today around agents, but I have the responsibility in an early talk, so I can at least add my own spin on this early on. And one of the things that I've been thinking about is this game. Does anyone know what this game is from? Yeah? Pokemon. You want to guess a color? Great. No, it's Pokemon Red, but very close. It's a Pokemon thing. And we're going to do, there's going to be a lot of Pokemon in this presentation. So if you love Pokemon, this is going to be great. If you hate Pokemon, you're probably going to hate 50% of this. Word of warning. But Pokemon is like really on my mind. I have young children, and I think it's incredible that Pokemon has like extended to generations. Because I never had like a game or a toy with my parents that like we both played. So it's really fresh on my mind, and especially when I'm thinking constantly about AI agents. And one of the concepts I think is like, maybe AI agents, if I wanted to explain this to my kids or to just anyone, is like AI agents are like Pokemon in a sense. And what do I mean by this? It's not just like I'm trying to like, I'm not sponsored by Pokemon at all, and Pokemon have not approved of this branding at all. But I do think there's some relevancy, and I'm going to kind of walk through this whole analogy. First one is that agents they do need a few things to become agents instead of just large language models or assistants. Just like Pokemon, if you've never played the game, Pokemon have specific skills that they can use, especially in the card game, and they're listed in the card here. When you go to battle Pokemon, that they are useful, and each Pokemon has their own unique skills. And in the same way, an agent is very similar. They need to have some sort of tools to be able to perform those tasks and knowledge to give them more context of when to perform those tasks. And I think there's, I was kind of on the money, I think, even before this analogy, because when we look at agent-to-agent protocol later on, they're actually all called agent cards to understand what knowledge and what tools an agent has access to. So it's kind of important. So pretty relevant. And this is kind of the more standard slide you're going to get, which is really, is in terms of an input as a user interaction. So you have system events. Again, when we're talking about tools, we can talk about things like APIs, databases, things that are equipping the agent to do something, and those have system events or things that happen in terms of responses to the agent. We have user messages, obviously the interaction between the user and the agent, and then also agent messages. So we're going to talk a little bit more about multiple agents, but the agents themselves need to consume other agents' messages to understand the context of the interactions between the user and the task at hand. So this is as an input, And then, in terms of the structure, right, we have a large language model. And lately, I would say, if we were looking at the world of large language models, there's less stress now on like which large language model to choose. There's obviously ones that are kind of positioned for reasoning, which is really good for agents in certain circumstances, as well as specialized large language models for different industries as well. Instructions are still very important here in terms of building out proper and clear instructions for the agent, and then the tools needed to actually access and complete those tasks. And the output is the agent's messages, but also the tool results. And this is when we're talking about evaluations later on, it's kind of important because we need to understand once an agent does call a tool or use a tool, what does the tool bring back? And this is kind of a rare case when when you implement this in code, it actually looks almost exactly what I said. Normally there's like, weird abstractions and things like that that aren't connected, but I think everyone can kind of understand what's going on here. This is some Python code, and it's specifically using Semantic Kernel, one of our open source frameworks at Microsoft for agents. And first thing is, we're going to define an agent. This is going to be a chat completion nation, mainly meaning that we're going to use a chat completion model. We have a service, so any service, Semantic Kernel is pretty agnostic. So this could be pointing to an Azure, this could be pointing to AWS, for example. And then we're going to have plugins, and this is unfortunately where the wheels fall off on the exact naming. Semantic Kernel was first and foremost an orchestration framework, so it allowed us to orchestrate different processes in large language models, so they kept as plugins. But we have other tools that actually call tools, but a plugin in this case is a tool, and in this case is a Pokemon plugin. We don't really know what it does per se, but we've defined it here. And then we have a name. Like all good agents deserve a name, and especially if you're working with multiple agents, agent 1, agent 2, final agent, probably not going to cut it because you're going to need to know, how these agents are interacting. And then instructions, which is you're a helpful AI agent that helps find the best Pokemon. And you might say, okay, well, best Pokemon, that could be very subjective. It's not very clear to the agent on what the best Pokemon is. But I think this is actually when we're talking about the value of agents, which we'll talk about next. Leaving this kind of open, best Pokemon, could be really important when we're talking about different scenarios when we want to use this AI agent, because best Pokemon could be the best Pokemon for the battle at hand, or best Pokemon for the different attributes that a best Pokemon has. And maybe, again, the benefit of using a large language model is this non-deterministic nature. We can use for flexibility for different use cases. So it's kind of cheekily put this best here, but it's kind of important when we're talking about different use cases there. And this is the next question you might be asking if you're kind of brand new to agents or agent skeptical, which is completely okay too. And that is, what are agents actually good at? And again, to really hammer home on the Pokemon analogy here, I think agents really are really good at doing things that are kind of open-ended, or you have a struggle in the ways that you would want to kind of define this. Like you could, if you were really good at like defining this through code, move to the left 3, because the task here is that we want to talk to this villager at the top. But what happens when the villager moves, for example, or maybe we need to go to that villager there to then talk to this villager below, or maybe the villager sometimes says things that are kind of crazy or not aligned with what we expect. If we were to like hard code this or make a workflow of this, we would need to then continue adding these edge cases beyond probably what's sane or what's possible, just to make sure that the task of talking to this villager or getting information then to pass it on to another villager is done. But with an AI agent, if we would say, well, the task is, talking to this villager because of, X reason, and, here's your available options, which is having a conversation with this villager, maybe just walking around and finding information, and we're giving these like options and availability, the agent should be able to design some sort of plan in a way to complete the task of either talking to this villager or, again, being adaptable. And again, another thing is that we might make a goal that to find this villager, and if this villager moves around the map, in those cases, then this is a very open-ended way to do that. And I understand maybe you're all not building Pokemon games out there, so we can get a little bit more realistic of these things. But what we wanted to consume in terms of the agent is this environment that it can play in. So much like Pokemon, again, they have very much options as a player or just a Pokemon. You can enter a fight, you can go to the battle if you see one, you can select other Pokemon. So again, giving options to the agent. You can have items. So again, maybe different tools that are out there, or you can just run, which highly suggested when you you go up against a Geodude, right? Just get out of there. But this is options that we're containing, the environment that the agent's operating in, and we design that as agent developers or designers in there. But in terms of like realistic use cases, right, we see across multiple different industries to kind of understand how agents are being applied. So on the healthcare side, not only are we just being able to diagnose or working with patients, but also even as researchers being able to even do things like drug development and provide different types of analysis that, again, would take hours, days, weeks, that an AI agent can consume and then present that over to a researcher. We also have things like travel and hospitality. And, the easiest one, customer service, you go in, agent comes in, you have a complaint, and then you understand what the complaint is. And maybe you go in and you pull answers from different knowledge bases, maybe you're working with other agents, but you're performing an action to make that customer satisfied. But one of the major benefits of using an agent as well is that they can also have things called long-term memory. So understanding interactions between users over time and not just in that context of the conversation. And what's the importance and benefits of that is that then you can have more personalized travel recommendations, and you don't necessarily need to maintain that in just in a static way, but be more dynamic based on the interactions of what the customer is telling you or the agent versus like a survey or something you send out to get their understandings. And then again, you can obviously pull that in from a database and use that as a context for the agent to interact with in the future. And then on the side of retail as well, locating products, recommendations, things like that is kind of really applicable when we're talking about agents outside of just the customer service use case. We actually have, to make this even more realistic for you, within Azure AI Foundry, again, this is our main platform for you're working with large language models, use cases where we've had either partners, data partners, or they have actually already implemented these agents in production, and then they've kind of built those structures in there, and you can kind of basically use these samples as either as a find and replace, or as even editing, customizing for your event for duty. I kept this slide up. This is I was gonna think about making this slide really pretty for you, and I'll make it really designed. But I really like that it's kind of very technical in terms of all of the different things that this was in place, just to have this sort of medical or diagnosis agent. And what you'll see here, we have about 5 or 6 different agents handling just one medical diagnosis or one way to interact with the patient. So we have like a patient history agent, which has a tool which is code interpreter. Basically, this agent can make design code or write code to extract information like clinical notes, medications, genomic data, all of that, right? So that's one agent. And I made that one basic, simple Pokemon agent. This is one agent in play here. And then we have a radiology agent that also takes any images. And I know from this use case that this large language model is not just like an OpenAI model, but a specialized model for radiology images themselves. So again, looking at how complex we can get in terms of building out multiple agents. And then we have like a pathology agent that uses another product, Page AI, and it's also going to be looking at different images. We have cancer staging and clinical guidelines and so on and so on. And they all have not only different specific tools that they need, but also specific knowledge sources that are quite important for their specific task. And when we're talking later on about multiple agents and how managing that, this comes into play, right? Because we don't want to just give agents everything that's possibly out there, but also giving them the data that they need and the tools they need to perform their specific task. And then we have the world of data, bringing in both from unified data from different sources, going out to the internet. So we can pull out things like clinical trials that might be important, and then even things like institutional knowledge if that's available in a technical way. But why would we use all of these agents, right? We're not just that seems maybe you're the type that you love this, or maybe you hate this. I don't know. Maybe you're like, oh, this is way too much for me to comprehend. But the reasons why we would want to use multiple agents rather than just a single agent comes back to our old friend Pokemon, right? Because basically, if you have never played Pokemon, they all have these different skills, and as they get experience, they learn new skills. Like Slowbro here has learned Rain Dance, which is a great tactic. And for whatever reason, I don't know, maybe Pokemon have some sort of memory limit that I'm not aware of, but they at least in the older games, I'm not sure about the newer ones, they have to forget some of those skills if you want to add the new ones. So you have to, like, as a player, make decisions on which skills you think might be important later on in the future. So you're going to have to remove some of those skills. I think you can add them later. I don't know. I haven't played in a while. But in the same way, when we're talking about AI agents, we don't want, we can give them all of these different tools that are out there because we think they might need them. But having the agent trying to decide on the different skills based on one specific task is going to cause a lot of confusion, especially in terms of when an AI agent and those tools are very similar in fashion, right? So in terms of like what they actually do. So we want to make sure that the agent has access to to a limited amount of skills that maybe are distinct, and that we can make sure that we get a lot of accuracy when the agent makes a decision to choose that skill. And getting agents to work together is also basically a skill in itself. This is in the world of like agentic patterns, and these are basically as AI research is growing. It's someone finds an interesting pattern that works, they publish a paper, and then it becomes on this slide, right? So this is kind of the process going on in terms of AI development. And we have a few different architectures or patterns that we found to be very effective. So, and this is kind of similar to how we would probably work as humans or colleagues. First is like the hierarchical structure, basically almost like a corporate structure, right? So you have this main manager, maybe like the CEO of agents, if you will, or like the director, and then you have middle managers, and then direct reports. So each of these direct reports or the agents are going in. They have their specific tasks, and much like you might do in your job, you report into the manager, and then the manager maybe summarizes or approves of all of those actions you've taken, and reports back to the higher structure to kind of move forward the process or end the process, which we'll talk about later on. We have a network where each of these agents are kind of connected and all communicating with each other. So they all have a kind of awareness of the different agents. When we talk about this in code, we'll look at it, but it's called the group chat features. Then we also have this maker-checker pattern, which is basically you have a worker that's producing some sort of content, some sort of answer, or some sort of task, and then you have a reviewer going back and saying if it's good or not, and then having the worker can continue on until the approver, whatever sort of trigger happens, that process is complete. There's also this handoff. So we have one agent that's has the main task. It kind of divides those tasks with other agents, and then as a sequential step, one agent completes that part, then hands off to the other. But we still need a kind of agent to go in and direct those that whole process. And the last one is custom, which kind of looks crazy, I'll be honest, on this slide, but it doesn't have to be as complex. It could be like you have a maker-checker pattern in a hierarchical structure for one side of the process, and then a handoff for another. But again, I would say when you're kind of applying this or kind of building this out, you're never going to get the right pattern the first time, I wouldn't say never, but in most cases you might want to experiment with different ones depending on your task just to see how they perform. And how does this actually look through code? Again, this is using something called Semantic Kernel. And there's two kind of things I want to highlight here, and maybe in the back you can't see it. I tried to use this orange color to brighten up everything. So hopefully you can see it. But there's two things. Again, if you don't read Python, it's completely OK. But first is that we have this selection strategy. And this is how do we choose which agent goes next in terms of this process? In this case, we have the agents, so we define them as that. And then we have history, which is all of the context, all of the conversations between both the agents and the users. And then the next thing I want to point to is the termination strategy. So again, we don't want agents to continue to be working constantly. That costs a lot, right? But we want to make sure that the agents know that whatever task or whatever job they're doing is complete. So we need to also define how when this task is done, the agents just stop doing what they're doing. And we can actually do this through natural language. So this is us just defining essentially the prompt. In this case, right, we're defining one thing called the facilitator. So this is the agent that's kind of at the top. the head honcho here of doing all of the facilitating of the agents, and we're making sure that the facilitator always decides on what agent goes next in the sequence, and it's doing that by looking at the context, what is the agent's being said. And then also, the facilitator is also going to be able to then say what's the default properties. And then lastly, which is really important here, because a lot of times when we talk about agents, it's like, not scary, but like these agents are going to just enter a group chat, and I'm not going to know what they're going to say or what their decision making is. We're going to have this facilitator say, okay, now you need to give a good full reasoning of your choice or verdict based on, this is again the patient diagnosis use case. Give me an explanation of why you've done that, and the verdict should be the name of the participant who should go next in terms of based on the conversation as the agents go on. So you have, as a developer or as an engineer, control of defining these rules and also responsibility to defining these rules in making sure that the agents are operating efficiently. And then lastly, like I said, the termination strategy, again, all through natural language here, we're going to be able to decide when to stop the conversation. And in this case, first, you're always going to look at the most recent message based on the conversation between the agents to determine if this conversation will end. And then we're also going to have basically as an artifact or a deliverable, if you will, for a kind of project side of things, report creation. So you're going to create a report based on that, and if it's aligned with the patient's status, we're going to terminate the conversation and move on. So what about knowledge? So if you ever want to, here's a pro tip for you. If you want to be like a AI influencer on social media, if you have dreams of that, you always want to find something that people are actually using in production, whether it's a model or a technique, and you declare that it's dead, right? That's like go-to, because you're going to get great engagement from that. And a lot of people are saying RAG is dead, which is a retrieval augmented generation, which is allowing large language models to retrieve relevant information, basically to answer queries from users. Is that we've been talking about it for the past 2-3 years now. A lot of people have it in production. A lot of people get results. Is it dead already? I don't know, but I feel like one of the things that we've looked at from the world of agents is how to use agents in the same way to retrieve information. This is a screenshot from a Pokédex. It's not that relevant to agentic retrieval, but I had to keep up with the Pokemon theme, so I added that there as well. But hey, it's a database of Pokemon. That's kind of where you can think about it. And agentic retrieval is basically, if you think about this concept, is if you were to ask, let's say, an agent, a customer service agent, something about security updates, and if you type this, security updates, and it's the update name, this is like very Microsoft update, security update name, then yeah, this would work really well. The LLM will know security updates, this name, and they get the relationship, and they'll go pull out this information for you. But no one really types like that. I don't think most people do. Maybe you do. But most of the time you'll do this. It's like, what does the security update fix? And what systems is it patching? And of course, there's a spelling mistake because no one really has time to correct spelling. We used to say it doesn't really matter with the LLMs. You can just spell whatever. They understand it. They'll find the relationship, and they'll know it. And that's true to a certain extent. But if we want to have proper retrieval and better results, we can actually use things like agents to kind of improve this query. And this is what we're talking about query planning and decomposition in terms of the actual question. So the first thing is that we're going to do is the easiest. We're going to correct the spelling. Let's just call it compatible with. So, again, when we need to look for this in other documents and stuff like that, we can find compatible much easier. And then we're also going to use the chat history for context, because maybe the user has already started this question to the agent or assistant here by saying, I'm looking for security updates or the latest security updates. And we want to make sure when we start looking for this information that we have the context and understanding that it's a security fix. So again, when we're looking in this world space of all these documents. And then we're going to split this query into different information. Because if you notice here, first we're looking for that security, and then we're also looking for the patch that's compatible with. So this is actually like 2 questions in one, even though there's only 1 question mark, if you will. So this is the world of agents using this and kind of decomposing all of these different parts, improving on it, so that when we do the search, it's an improved search. And this is not just like, AI people just making up a new thing just to make it up. We actually see actually way better, improvements in performance at least, both from a relevancy perspective, right? So 40% in terms of retrieving that, and then 30% that the actual results in terms of the information that's being brought about. So, but the content that we're retrieving is important, and also the answers that the agents are in providing are more relevant based on that. It's not too crazy in terms of actual implementation here. We have this thing called Azure Search, is kind of our vector database. In this case, we're going to find an agent, which is this retrieval client. We're also going to, like I mentioned, one of the things that's important, what's different here is that we're also taking context, again, the interaction between the agent and the user, in consideration before we start searching. So we're also, in this case, we're going to get 5 of the last messages and kind of include that and give it to the agent to understand in terms of what's later on. And then we're also going to do basically the re-ranking, basically where we take all the queries and then we see how relevant those queries are based on the question, or the information is that we retrieve based on the question of the user. And then one of the nice things is that we can also, if those aren't as relevant, the agent has decided that, we can even do another search or improve the query, or rewriting the query in some type of way. All in kind of a few lines of code here, just to get 40% or 30% improvements on retrieval and answering. But what is this all about MCP? There's a whole talk, I think, on MCP later on, so I'm not going to steal anyone's thunder here and talk about MCP for the rest of the time. But I will give you some brief overviews, because again, that's kind of the idea of this talk. And Pokemon, I don't know, again, if you've never heard of Pokemon, this is going to be a whole experience for you. But Pokemon, they evolve. So Pikachu here, and we have Raichu here, and they evolve over time because they get more experience and they learn new skills. But it doesn't mean that Pikachu is not worthy anymore. We don't get rid of Pikachu. It's just that it turned into a new Pokemon. But you can still use Pikachu in different use cases. And it's also very important because you don't get Pikachu without you don't get Raichu without Pikachu. And I would think there's a relationship between APIs or HTTP in terms of the protocol and MCP, the Model Context Protocol. And what do I mean by that? Well, there's a few things to understand about MCP, and again, this is going to be very high level, but MCP is an idea or protocol around that we have certain artifacts that are, when we present it to an agent, are better to consume or the agent to use versus if we were to use that just in APIs, and it also makes it for a better developer experience, which I'll show you as well. But there's 3 main artifacts, which is the tools, which again, that's something I mentioned before, but in terms of being able to use whatever service or whatever platform that's connected to this MCP server, and that's one of the artifacts that gets returned. Then there's also resources, which is like documents and files, and then lastly prompts, which is our kind of templates for the interactions between large language models, mainly the agents. And I like to say this, MCP is an abstraction, but that doesn't make it not useful. Like browsers are for users, so I don't want to make API calls for every time that I want to open up an app on my phone, right? It does happen, but the application, the UI, is where I'm, as a user, implementing that. APIs are primarily for developers, right? You love working with APIs, things like that, and how they change. APIs are where the developer focuses, but we needed to have an abstraction specifically for AI agents in terms of them understanding those tools and how they sort of operate. And again, there's actually, in most cases, an API underneath an MCP server. And that might be then I get a lot of pushback. Then why would I then do this MCP thing? This seems really ridiculous. This seems like an extra engineering work. And one of the biggest, I think, benefits of using MCP is this discovery at runtime. So you might, as a developer, if you're a developer, go to, if you're integrating a new API, go to the docs, and you see all the endpoints, and you kind of understand some of them. And maybe they even also change over time, so things like kind of break. There's different params that you need to get perfectly, or the request will fail. Maybe there's authentication that you need to do all these other steps, generate a token, this and that. Well, MCP servers, instead of having all these docs and things like that, they actually expose all of the available options to an AI agent at runtime. Meaning, when a user says, "I want to, get a GitHub username for Korey Space and understand, his latest repositories," it goes and it calls this MCP server, the GitHub MCP server, and the MCP server responds and says, "You can do all of these things." at runtime, not a request response, wait, let me see what's available, or me having to develop or code that. It's all at runtime, and the agent then understands how it can use the MCP server to complete this task. Another thing then is that, okay, well, great. I will just take my API endpoint and I will make it an MCP server. Korey, I hope you're satisfied. You've done it, right? And we even at Microsoft have a tool specifically for converting APIs into MCP servers. But it's not necessarily a one-for-one like ratio, because if you remember, like I said, you might, as a developer, go to your docs and you see all these endpoints and what they can do. If you gave that to an AI agent, and again to the point of giving an agent loads of tools and just saying, good luck, hope you find the right one, that would be the same way if you just chose all of your API endpoints and gave it to made into an MCP server. Agents might actually struggle to determine which endpoints or which tools behind those endpoints are relevant. And also there's some benefits because you can actually do things like combining different endpoints or different processes of what those endpoints are. So you can, I've seen a good demo where it's like migrate a database where instead of just migrating a database as an API endpoint, they also migrate the database, they create a branch on a repo, and they create all these processes behind one endpoint versus just having this one-for-one ratio. So something to think about when you're kind of exploring the world of MCP. And like I said, I used to work in integrations, and I used to love APIs. I was like, I speak API. That's my language. So I used to love go to docs, find out what's there. And if I wanted to integrate this with an API using Semantic Kernel and just getting this GitHub plugin, again, this is like a tool, then I would need to define the URL that's available, make sure I had the param, which is the username, and basically then the agent needs to make sure that it gets the username param from the user and then makes the request. And then let's say, oh great, the GitHub changed their API endpoint, and now I have to go back to my code and put, user instead of users, all of these things. And again, maybe the params, again, like the name, the description, these things change all the time. So this is I have to integrate this multiple times over time in terms of as a developer or engineer. But with MCP, I'm doing the same thing in very much few lines of code. I'm using here a chainlet, which is like a UI element. But basically, I'm allowing the GitHub plugin to make a connection, which I've defined here, description, giving a description, and the arguments that it needs for connection. Then I'm also making that connection. Again, this is more of a chainlet thing, but just showing it to the user that we've connected, which is kind of important from a user interaction. And then, oh, great, I have a kernel, which is how Semantic Kernel manages LLMs and tools. I'm going to add this as a plugin, and boom, my agent now has access to all of the tools behind the GitHub MCP server. So when a user asks about usernames or repos, boom, it gets it right then, right there, and I don't have to integrate this ever again in terms of, okay, GitHub changed something, because once it changes something in the MCP server, the agent's kind of aware of that. So another thing is about agent-to-agent protocol, or A2A. So again, I think this is the last time we're going to talk about Pokemon, so hold your horses. So, so Pokemon, they all listen to these things called Pokeballs. So, and your agent, when you first make them, they're also kind of coexisting in a Pokeball, meaning they're all in their own environment. Maybe you have multiple agents, but they're all not necessarily communicating with the outside world in terms of retrieving other information, in, not from a tool perspective, but from other agents themselves. And that's kind of where agent-to-agent solves some sort of problems. So first is that agents, they need to be able to discover each other. There's not, unfortunately, like a agent LinkedIn, but I also have seen people try to build this, so that could be something like that in the coming future where you have this marketplace of agents, and you can just say, I want to use this agent later on in my business or have my agents interact. They need to work on completing different tasks. So like a multi-agent where you own all those agents or you've created all those agents, you might need to have another agent that's, again, not within your organization or not something you've developed, but again, want to have that interaction. They also need to handle long-running tasks. So you can't just say, I'll just expose my agent as an API, because we're not talking about millisecond responses here. It could take minutes, take hours, it could take weeks, depending on your process. Maybe you have some crazy reasoning thing that you're doing. So we need to make sure that the agents are kind of waiting in place, basically in terms of waiting for responses, but not expecting something immediate. And then, like I said, since you're communicating with the outside world, if you will. You also want to make sure that your agent is not exposing data to another organization that could be really relevant, or exposing not to another organization, but also to outsiders kind of watching this interaction going in play. So it needs to be secure. And basically, A2A kind of sits between that, right? So you have their agent, so not us, but their AI agent, they have their whole tool set, they have their own knowledge, they have all these sort of process there, and then you have your agent that you've designed and you made a beautiful agent for. And the way to make this sort of communicate is we needed a protocol in a way that's not just HTTP again, because it doesn't necessarily address all of these concerns, but a way that's specifically for agents to understand passing over things like task, understanding that there is a task in place, understanding to wait for a response, and lastly, once that task is complete, handing it off to another agent saying, hey, I did my job. So that's where ATA protocol lives. Like I said, there's a couple of things here, is that there's agent cards. So again, this is again like the playing card of your agent. It has things like description, which again is really relevant when you, not only for a user, but for an agent to understand what is available. URLs and things like capabilities. Again, I told you, those Pokemon cards, really relevant. This is like the same thing, but for agents. And again, we can kind of define that. We can give descriptions about those agents. We can give tags. So that's really good in terms of finding that agent. And then lastly, LLMs love examples, so we can even give examples of how this works. Then, we can do things once they actually communicate, execute the context. So basically passing over the context of what the user's been interacting with already. The event queue, so again, making sure there's a queue in terms of being able to communicate when you're done. And then lastly, the task. This is the context, the current task that the user's asked for. And then lastly, when it's all done, we have an artifact that comes in when the agent's done completing that, and that gets passed over through the protocol to the agent saying, the request is complete, and that's what gets tracked in there. So now to kind of finish up, now how do you know if you're doing this really well? Like every good Pokemon master needs to monitor the health of the Pokemon, and you should monitor the health of your AI agents. One of the ways, again, a big concern is the evaluation. There's many different ways to evaluate agents. First and foremost is like intent resolution, making sure that the agent understands the actual question here. So the user wants to know the local weather in current time. So weather now is not current time, but now it means current time, right? So the agent needs to resolve that. Then the agent needs to call 2, maybe 3 APIs. Location, where's the weather now? Where's the agent? Where's the user? Agent needs to decide that. The time, so this now, what's the time currently? And then lastly, obviously, the task at hand, the weather API. So you want to make sure and evaluate that the agent is actually doing all this. And then lastly is the response, right? So we don't want to say, the weather, we wanted to say 30 degrees. Like that's not really a great interaction between the user, right? I mean, maybe that's answers the question, but we want to make sure that the task adherence, like the response that it gives to the user, the temperature is 30 degrees, is correlated to the weather. And we could do this, again, by just deciding different evaluations. Again, this is through the Azure AI Foundry for that. But how do you want to do this all the right way and to conclude, right? Because I hope you want to be the very best AI agent creator, or Pokemon master. And that's, if you want to take away from anything today, is there's 4 primary things to concern. 1, prompting is always going to be important here, giving clear instructions to your agents. Second is the actions, making sure that they have the right tools and access to those tools later on to complete the task that you think your users will be asking for. Making sure you also choose the correct pattern, especially when you're doing multiple agents, and also exploring those different patterns out there. And then lastly, even though we didn't talk about security, but the evaluation part, security, making sure you're using protocols that are accepted, MCP servers that are secure for this, and then monitoring to see how this is all going down over time. This is my last slide here in terms of saying, in all honesty, this isn't always easy, all right? I've showed you some code that looks easy, but getting this into production, getting to users are always going to be ways to learn. I'm not going to sing this, but this is the Pokemon theme song at the end. But basically, I love it because it says, you teach me and I'll teach you, which I really love. If you've watched Pokemon, you can probably hear it in your head now. But like I said, my main goal is education from a Microsoft perspective. So we have a lot of different free courses out there. This is on GitHub repos. This is the AI Agents for Beginners, which I'm the content lead for. Again, this will get you started. It's 11 lessons now, or 10 lessons, but it'll actually expand later on in the summer to about 15. And it'll cover a lot of the design and agentic design patterns that I mentioned. Then we also have this MCP for beginners. I showed you Python code, but we actually have different samples from TypeScript, Java, JavaScript, C# to actually implement MCP in different practical and ways. So again, like I said, very easy to talk about it, but much different to just sort of implement this technology. And then lastly, I'm also part of this developer community. Like I said, it's really important, not only if you don't use Azure, but if you are just trying to understand how other people are building things. We have Discord. Anyone on Discord here? Yeah? OK. A few people are proud of it. Some people are. I know a lot more people are in Discord. You're just like not fessing up. But Discord, great. We have product teams that come in and give us kind of master classes and workshops on that, as well as myself. And then there's discussions, GitHub discussions as well. So that's the wrap up. I think I have like 1 minute maybe to take a question, but I'll leave this up because it's probably the most important for the conference. We do have a feedback form here. I made this QR code, so hopefully it goes to the right place. But if not, there's a URL here to rate the session and give any feedback that you have. But yeah, thank you.